Students, I think the part of straight lines that we have done till now will give you a quite of interest in this chapter. So moving further, in the next part we have concurrency of straight lines and the position of a point with respect to a point. We'll see if a point is lying above the line and lying below the line, what are the mathematical conditions that we can look into. So stay tuned to get the further details. Position of a point with respect to a line. It is one of those concepts in straight line which is very useful where you want to club the questions of quadratic functions with a straight line, because this is going to talk in terms of inequalities rather than equalities. So let us see what this concept is specifically. Let the given line be ax plus by plus c equals to 0. So we have a straight line. Suppose this line is represented by this, and this point will be nothing but minus c by a comma 0, and this point will be nothing but 0 comma minus c by b. You'll get these points by putting y equals to 0 for this and x equals to 0 for this. So this is, we have got the point. Now we have a point alpha and beta whose position we have to check. So for that, what we have to do, we will take the point, suppose point P, alpha beta is over here. So we'll draw a line perpendicular on the x-axis, as this will be a line whose equation will be nothing but x equal to alpha. As you can see, the value of x is always going to remain alpha on this line, and so the point at which this line is going to intersect the given line, the x coordinate will be alpha. And if the x coordinate is alpha, we can find out the y coordinate by putting x equal to alpha in this equation. After we put the value as alpha for equal to x in this, the value of y will be nothing but minus a alpha plus c upon b. Now take this value as beta dash. Now the comparison is very simple. If the beta which is given is greater than the beta dash, the geometry will tell you that point P is going to lie above the line. Let us give it a different color, and that to yellow. If this is going to be the condition, the point is going to lie above the line. If it is equal to 0, this point will satisfy on the line, and if this is less than, the point will lie below the line. So this you have understood. And now suppose I am taking it as an example, y equals to mx is plus c is the line, and y minus mx minus c will be the function in terms of line. So if we'll put values of x and y is greater than the y dash which is required, so this will give you the y point, and this is suppose the y dash. So if it is greater than 0, you will get a point which is above the line, and if it's less than 0, you will get a point which is below the line. So we will use this concept to determine the position of 2 points with respect to a line. So this is the condition which we'll use for position of 2 points with respect to a line. Consider the line, the same line, ax plus by equals to c, and now we have 2 points P and Q. How we are going to deal with that? Now if minus ax1 plus by1 plus c upon ax2 plus by2 plus c is greater than 0, consider by putting first point P into the line and putting Q into the line. See, if the ratio is less than 0, what we can say that both ax1 plus by1 plus c and ax2 plus by2 plus c are of opposite side, then it is pretty sure that the points are going to lie on the opposite side. See a picture. Suppose this is the line and this is the point P and this is the point Q. See, if this would have been the condition, beta dash would be greater than beta, right? And beta dash is less than beta. We are doing nothing but taking out the subtraction, and if one subtraction is positive and the other one is negative, we'll get a negative sign. Hence it is self-explanatory that the 2 points are going to lie on the opposite side. But suppose this happens, that minus ax1 plus by1 plus c upon ax2 plus by2 plus c is less than 0, which in turn will give us that ax1 plus by1 plus c upon ax2 plus by2 plus c by2 plus c is greater than 0, which will be a clear indication that if this is the line, either both the points are over here or both the points are over here, because I can get a positive quantity either by dividing two positive quantities or by dividing two negative quantities, which is a full proof show that both the points will lie on the same side of the line. So always mind this condition whenever we are dealing with position of a point with respect to a line. Next in the series is concurrency of three lines. To prove this as a concept, at least we require three straight lines and their equations. So let us consider that we have three lines: a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0, a3x plus b3y plus c3 equals to 0. Now take it as an example. If you have three different lines, the area of triangle made by them is going to be something, right, some value. But if all the three lines are going to pass through a common point, they will not make any triangles, and hence the area of triangle that we are going to form with these three lines is going to give us a 0 area. So this concept is directly being inserted over here while we try to prove the concurrency of three lines. This is the formula for finding out the area, or to be exact, this is the formula for the area of triangle. But if the area of triangle is 0, I can multiply both sides by 2, and hence the answer is still going to remain as 0. So the determinant of the matrix, in which the first row is the x coefficient, second row is the y coefficient, and third row is the constant part, will give us 0. If the coefficients of x, y and the constant part follow this trend, the three lines are going to be congruent. And if you are not happy with this, what you can do, first of all, try to find out the point of intersection of any two lines, and the result generated from that you can put it into the third one to get the final equation. So there are two methods. First one is finding out the intersection point and then putting it into the third one, or the second one is finding out the determinant. Whichever you like, you can prove the concurrency of the line using that method. In this part, you have seen that how we found out the mathematical condition for concurrency of straight lines and the position of a point with respect to a straight line. And you have also seen whenever we have to prove that lines are congruent, we use the property of area of triangle equal to 0.